Definition of work. Work is usually defined as a force F acting through a displacement X, where the displacement is in the direction of the force. That is This is a very useful relationship because it enables us to define the work required to raise a weight, to stretch a wire, or to move a charged particle through a magnetic field. For example, we can have to find the work requires to raise a weight stretch a wire or to move a charged particle. Through a magnetic field However, when treating thermodynamics from a microscopic point of view, it is advantageous to link the definition of work with the concept of system properties and the process. Concept of system properties and process. We therefore define work as follows. Work is done by a system if the sole effect of the work defined as if the sole effect of the surrounding could be raising a weight. Work is done if the sole effect on the surrounding could be raising of a weight. So work is done if the sole effect on the surrounding could be raising of a weight. Notice that the raising of a weight is in effect of force acting through a distance. Notice also that our definition does not state that a weight was actually raised or that a force actually acted through a given distance, but only that the sole effect external to the system could be raising of a weight. Work done by a system is considered positive and work on system is considered negative. The symbol W designated the work done by a system. W. In general, work is a form of energy in transit. Work is a form of energy in transit, that is energy being transferred across a system boundary. Energy being transferred across a system boundary. The concept of energy and the energy of storage or possession was discussed in detail in section 2.6. Work is the form of energy that fulfills the definition given in the preceding paragraph. Let us illustrate this definition of work with a few examples. Consider as a system the battery and motor in this picture, part A. Figure A, part A, shows a battery that and motor, and let the motor drive a fan. This fan. does work across the boundary of the system? To answer this question, using the definition of work given earlier, replace the fan with the pulley and weight arrangement in Part B, this picture. As the motor turns, the weight is raised and the sole effect external to the system is the raising of a weight. So at Part A we have motor driving a weight, and B is the replacing the driving a fan. With pulleys and weight. So the net effect, sole effect, is raising a weight. So in this case we have both. Thus for our original system of figure Part A, this picture, the fan, we conclude that work is crossing the boundary of the system, since the sole effect external to system could be raising of a weight. Let the boundaries of the system be changed now to include only the battery shown in the picture 2. We have another example for the definition. We change the boundaries to the battery only. The boundary is here, for example. Again, we ask, does work cross the boundary of the system? To answer this question, we need to ask a more general question. Does flow of electricity energy across the boundary of system constitute work? The only limiting factor when the sole external effect is the raising of a weight is the efficiency of motor. However, as we design a more efficient motor with lower bearing and electrical losses, we recognize that we can approach a certain limit that meets the requirement of having the only external effect with the raising of a weight. The sole effect of electrical batteries flow from battery is raising a weight with, for example, some losses, but the only effect of the battery power is the raising effect. It is another example for the definition of work. The next section is about the unit for works.